Intro, day 2. Tomorrow we'll get in, or tomorrow, Monday, we'll get into application. So um, the purpose is that on Monday, the only thing that changes is that instead of me explicitly telling you the shape, which kind of always still does, we just add context. So that's the only difference. I've seen on multiple choice questions, typically in a multiple, you'll get at least one multiple choice question on related rates, and it'll be like a circle, a rectangle, and then in free response, every few years, I would say, maybe every 2, 3, 4 years, there's one related rates problem that shows up. I've seen a related rates problem be the only problem that shows up on the exam, and are only is the it's not only on the one, but it's one of the questions. My words are cutting out. Okay, that is good to know.
I think you're Yeah.
Okay.
It's not the muted. I think like his other thing is going in and out. We can't hear you.
Thank you. I just looked over and it says connecting. Can you hear me on this one right now?
Yeah.
Okay. There's all right. It looks like it's back connected. Back connected. Can you hear me now?
Yes, we can hear you. Yep. Yes.
Okay, it was my iPad had disconnected from the internet or disconnected from Zoom. So thank you. Thank you for letting me know that. So that if that happens, just let me know, um, and then I can get it fixed right away. So what I was saying was that typically on the AP exam, there's one multiple choice question that's related rates, and they tell you explicitly circle, rectangle, or whatever shape it is. Um, there has been questions on the um, free response where one of the 6 questions is an entirely just the related rates. It doesn't happen often, and some teachers will gamble, and they'll be like, "I'm not going to cover related rates," and therefore, or we're going to cover it very lightly, and then it turns on the AP exam. I personally like related rates. I find it a very interesting topic and very applicable, especially, and I know some of you out there want to be engineers. So related rates is a very important topic with that. And let's go. Um, before we get into the new shapes, let's talk about um, constant variables. Um, in some related rates problems, one of the variables typically a side length is constant. As such, its rate of change is what? The rate of change of that side length. If a variable or if a side length is constant, then what would its rate of change be? What would the rate at which it increases or decreases with respect to time be? Remember, when you think rate of change, you should be thinking derivative. Don't overthink it. This is the easiest one in all of calculus. And in regards to what the answer is. if the variable is a constant, then its rate of change, aka derivative, is 0. All right. Its rate of change is 0. I.e., if x is constant, then dx dt is 0. Okay. So in like the example yesterday, we had a rectangle. What was that? We have a rectangle with sides x and y. Okay, so when they tell you the variables to use those variables. I know my formula says L and H. You should use the variables that are listed, just because they might ask you. They will explicitly ask you for like dx dt, for example, especially on a multiple choice, with sides x and y, with x equals 5 inches and y equals 3 inches. Oh, you see the wife. She popped in the view. There's a wife roaming the area. Have a good day. X is increasing by 3 inches every second, while y is constant. Find dA dt. Now, one of the things we're going to try to introduce a little bit more is try to, what can often help you is to draw a quick picture of what's going on. So we're dealing with a rectangle. We have x and y. Now, I'll get into that actually. And I know that x is 5, y is 3, dx dt is what?
+3.
+3. Now, why do I know that? There's two different reasons. Can somebody tell me one reason why I know dx dt is 3?
Because your x is 5 inches, and then it says that x is increasing 5 inches, so that has to be the derivative.
Good. So that is one reason. So that is one reason why you can recognize why dx dt is 3. There's also something very subtle about something in that sentence that also tells you that 3 is a rate. What is it?
That is constant.
Sorry.
Inches over seconds.
Yeah, it's the units. So because it's inches per second, I know that it's a rate as well. So these are just little. That's a little subtlety. Most, as Farida was saying earlier, that's usually the number one rate students recognize. We recognize that that it's a rate. But the other way that we can recognize it is inches per second. And when it's inches per second, that tells me one side length. For example, if it said inches squared per second, I would know that that can't be a side length because inches squared is an area. So it'd have to be dAdt. Now, that's not going to be important today, but on Monday, it can be when we talk about the applications of problems and they get a little bit more wordy. So I have that. Now, so what is dy dt?
0.
dy dt is 0. Now, we're going to solve traditionally, which means just we're going to do it as we normally do it, okay? So area equals x times y. We did this yesterday. So dA dt is equal to dx dt times y plus dy dt times x. I want to find dA dt, so dA dt is equal to 3 times 3 plus 0 times 5, which gives me dA dt is equal to 9 inches squared per second. I hope you were able to follow that as I did in that way, because basically it was the same problems as you did in your homework, and basically this was the same example as we did yesterday, with the only difference being that dy dt was now 0. Does anybody have any questions about solving that problem in the traditional way that we just did it?
No, the other thing we do delta math.
Yeah, what?
The other thing we do delta math.
Yes, it's the same thing. Same thing on your homework last night. That's what I
I
had.
have a question.
Uh-huh.
Where, like, on a diagram, where would dA dt be with x and y? Oh, it's the whole thing. Oh, okay.
Yeah. So maybe I'll draw it in a different color here, because you want to go to you want a formula that relates it. So if it was perimeter, I mean, you really don't usually write the left-hand side or the formula or variable. For example, if it was perimeter, I wouldn't write that. Usually what you have labeled, when we talk about labeling, we're talking about labeling the right hand side of the formula, or any lengths is what we typically label in a diagram. So when I say label the one dimensional lengths. Does that make sense?
Yes.
Okay. Now, when variables are constant, there is a more efficient method to solving related rates problems. Sometimes it's the only way to solve, or at least the only way to realize what you need to do. So in this problem, for example, when we did this, we had 4 variables, or we had 2 variables which turned into 4 in the rate of change because they're derivatives. So in order to find dA dt, you need a dx dt, you need y dy dt, and you need x. However, in this problem, it is possible that I didn't even have to give you x. So for example, if I didn't give you x, it would not have mattered, because x was going to be multiplied by 0, right? X ends up being multiplied by 0. And so therefore, if I didn't give you the x value, you would have still been able to find the answer, because it would have just been 0 times some other number. So if I didn't give you this value, you could still have solved it. All right. A lot of students will look at this formula and say, okay, I know dx dt, I know y, I know dy dt, but I don't know x. So then they get confused, and then they start trying to find x so that they can end up finding dA dt. But it turns out that when you plug the information into the formula, you wouldn't even actually need x, because it's being multiplied by 0. So this next method is a more efficient way of doing the same problem. So if a variable is constant, plug into diagram and formula. But only for constants. One of the mistakes that students will do is when they label their diagram, they'll label the diagram and they'll put the actual values into the diagram. So, for example, so when we go into this, back to this previous example, when we drew this and we said we drew it as X and Y, and some people will do 5 and 3, okay, like this. That's bad. You don't want to do it like that, okay, because that's saying that it's always 5 and that it's always 3. So that's not true. What we can do in this problem, though, we know the y is always constant, so we can label this as x down below, and we can label this as 3. And this is okay because what this says that y is constant at 3 always. When we said that x equals 5 at the instant we are doing the problem. Because we know that dx dt was 3 inches per second. So, and I usually don't ask these type of questions. So 1 second later, x will be equal to 8. 2 seconds later, x will equal 11. So every second, x is increasing by an extra 3 inches. That's what's kind of going on in this problem. So every second, x is going up by 3 more inches. So at this instant that we are doing the problem, x is 5. A second later, x is 8. Another second later, or 2 seconds later from the original problem, x is 11. So every second, x is increasing by 3. 3 more, 3 more, 3 more, 3 more. So that's why we keep it as a variable. But y is 3 seconds right now, or 3 inches right now, and later on, a second later, it's still 3. 2 seconds later, it's still 3. It's always going to be 3. So when solving this problem, we said area equals x times y. Well, we're going to say area equals x times 3. Because y is a constant. And now when I find dA dt, what is dA dt? Remember, x times 3 is the same thing as 3 times x.
3.
3 what?
3 dx dt.
3a dx dt. All right, so the y went away. There's no y in my formula now because y was a constant, and therefore dA dt is 3 times 3, which is 9 inches squared per second. So this is a more efficient way of being able to find the answer. While it doesn't seem like you can do it now, later on, when some of the problems you're going to see today, it becomes like if there's 3 variables, for example, you're like, whoa. But then if one of the sides is constant or even 2 of the sides are constant, it can be very helpful. Okay, so there's that part. All right, so let's look at the other shapes. More formulas and the rate of change formulas. So let's talk about the circle. All right. So in the circle, we can have area equals pi r squared. Okay. So its rate of change formula would be that dA dt is equal to pi is a constant. And so this is just a power rule problem, or power chain rule technically. How do I take the derivative of pi r squared?
Would it be pi and then 2r?
So
And then
2 pi, so pi 2, so the 2 you could just bring all the way into the very front.
oh, yeah, so 2 pi and then would it be times dr dt?
Times r.
Oh.
All right, so then it's technically r to the first power, and then times dr dt. All right, because that 2 comes down, and then we subtract the power by 1, but then we have to, don't forget the baby in regards to the chain rule, which gives us that times dr dt, which we know we should have a dr dt in the answer. Let's do another circle one. Circumference equals 2 pi r. dc dt is
Is it the same thing?
It is not, but it's very close.
Is this a product?
It is not. 2 and pi are constants. It's very close to the previous
So
answer.
would it be 2 pi and then instead of having the r there, it'd be dr dt?
There we go. Now, I want to point out some stuff, and you're going to see this in your homework. Did I put it? No, I didn't put them on your homework today. Actually, I think I have them on Monday. But I'll bring it up at least right now. But I'll cover this a little bit more on Mondays, because Mondays is when you have your delta math again, and so these are going to happen and pop in there. You could be asked for dAdt given circumference. So they don't give you pi, they don't give you r, but they give you like the circumference in here. So I've seen these type of problems happen, or they try to do in some type of relationship. Notice that there's the 2 pi dr dt. So technically you could say that dA dt is equal to dc dt times r. So this is technically a true statement because 2 pi dr dt is that. So you could actually create, and I've seen in multiple choice questions ever so often pop up, and they try to say like, what is the formula for dAdt in terms of dc dt or something like that. It happens with those. And so you can see that 2 pi dr dt, dAdt has a 2 pi dr dt. So you can actually find it in regards to dc dt. However, there are other problems where they give you the circumference and then they ask you for dAdt. Well, if you're given the circumference, you can find r from the circumference, all right? So if you're given the circumference, you can find r, and if I give you dc dt, you could find dr dt, right? You could solve for dr dt, and then have to plug in those informations into here. That's about as challenging as it gets for those for these two-dimensional problems. Is when they try to give you, they really like try to do. It's called a two-level problem, or a two-formula problem, where you have to use two formulas, and you're going to have to use the rates and the information in order to find what you're looking for in the problem. You'll get those on your Delta Math on Monday. you'll get those type of problems as well as problems that are applications in your Delta Math. All right. What was the other shapes I have? What was the next shape that was on your notes?
Sphere.
Sphere. Should have just done it like this. So sphere. We have volume equals 4/3 pi r cubed. The other one is surface area equals 4 pi r squared. And the same type of relationship ends up happening over here as well. All right, so let's take the derivative of these. Now remember, the goal here, the real goal, is that you can find the rate of change formula on your own. But and if it's the AP exam, you're going to have a hard time, or we'll try to structure that if you can end up using your notes because it's open notes. If like it was last year because of the remote learning, we'll work to structure it and find different ways so that you can find your formulas. I have things that I build, but in reality, you should be able to find them on your own as a calculus student. So, what is dv dt?
Is it 12/3 pi r multiplied by dr?
Not r. Stop.
R squared.
R squared.
Oh yeah, r squared. I forgot that part. Multiplied. Is there a baby?
Mm-hmm.
I'm lost.
It's always the same baby. It's always the same baby.
Dr dt.
Yeah.
Yeah.
Now, you said 12/3. You can just say 3 because when you get over here, the 3's cancel each other out when you bring in that 3. So it's 4. 12/3, which is 4 pi r squared dr dt. Now, you can also notice in this 4 pi r squared is s, so you could say technically that dv dt is equal to s times dr dt. I've seen a question that asks you about volume and surface area relationships, so that's just also something else there. And ds dt is
4
no
pi r.
no
8 pi r times dr dt.
times dr dt. All right, you got to bring that 2 down. So these are all, and I want to reiterate, these are not the actual AP questions, right? So these are what you need to do. Is these are always an intermediate step. They'll never ask you, and I will never be asking you as your actual question, what is the rate of change formula? You need to find those, or you need to be able to do those to answer the actual question. So we're putting those out here now so that we can have it. What was the next shape? Was it rectangular prism?
Yeah. I thought it was a cylinder.
Oh, okay. Yeah, so we'll go with cylinder. So a cylinder is volume equals pi r squared times h. This one is a little bit more difficult. Now, there's oftentimes with these cylinder problems, though, the good news is that most of the time you get a cylinder problem, or most of the times you get three-dimensional problems, one of the side lengths is constant. That's what happens the majority, I would say like 60% of the time. So like R will be constant, and we'll talk about how R can be constant in a problem like tomorrow. Our height will be constant. I say tomorrow, I mean Monday. So, for example, in real world applications, if you're looking like at a cylinder, like a can of soda, with cylinder, right? And if you fill in the water, we'll talk about that's the volume. Then the radius of the cylinder is always the same as you go up. So radius is constant, but height is changing with the level of the water. Or if you were to put something like in an oil spill, and the oil is sitting, it's like 3 inches thick, but it can't go any lower than that, and so it's 3 inches thick, and it's just spreading and getting wider and wider. So you have a cylinder that's growing like that. You have something that the height would be constant. Just some examples right there, and that's what's more my focus on Monday rather than today. So we'll get a little bit more difficult now. What is dV/dt?
Would it be
Before we go,
2 pi r?
before you tell me what the answers are, what are we going to have to use?
Is it a product rule?
This is a product rule. So this problem is a product rule. We'll write it out and we'll clean it up at the second piece right there. So dV/dt is equal to u prime. So what is u prime? We've already done it.
2 pi r times dr dt.
Good. Times
H. H.
plus v prime.
dh dt? Or it's just 0?
No, dH/dt.
Okay.
Times
pi r squared.
Times pi r squared. And so just to clean it up, dV/dt equals 2 pi r h dr dt plus pi r squared dh dt. But in reality, when you do it, you're going to do it like that. So it's a product rule. Surface area is 2 pi r squared plus 2 pi r h. When talking about this piece right in here is the top and bottom of the cylinder. And this right here is the lateral surface area. All right, so some questions will only ask you about the lateral surface area. So you only have to do that part and you ignore this part. Some problems will ask you the entire surface area for the cylinder, which means you just combine the top and bottom. So it's 2 pi r squared because there's a pi r squared on the top and there's a pi r squared in the bottom. But we're going to do this formula in its entirety. So ds dt is equal to, and we're just going to take two derivatives. What do I get?
4 pi r times dr dt.
Good. Plus.
This is a product, right?
Mm-hmm.
So it'll be plus 2 pi dr dt times h plus dh dt times 2 pi r.
There you go. So I'm leaving them there here so that if you do need to reference them, you can go over and check it. My advice for you is when you do the work, you try to take the derivative on your own And then you come back to look at these notes and see if the formula matches. These should be all of the formulas that you are using, at least for today. There are other type of problems where they give you some special relationship between variables, which we'll talk about. And so therefore, I don't have the formulas for those ones, the rate of change formulas, because it's technically not a formula, it's just a relationship. But you should have all the formulas you need to use on this. Yeah, this in yesterday's notes. Questions? And so I'm spending a little extra time going over these formulas where you can be able to do them on your own, but we're doing them in here. We have the time today. Rectangular prism, volume equals length times width times height. Now this is one that is almost always given, one of them being a constant, okay? Typically one of them is going to be a constant here, but in this one I've never really showed you how to take the derivative of. This is what we know as the triple product rule. But for notes purposes, so in other words, this wouldn't happen here. I'm just going to give it to you. So it's dv dt. And the triple product rule is the derivative of the first times the other two, plus the derivative of the second times the other two, plus the derivative of the third times the other two. So dv dt equals dl dt times w times h plus dw dt times L times H plus dH dt times L times W. Typically, that's what's going to happen with these types of problems. All right. If volume was equal to like 5 W times H because L is a constant, then dV dt would equal 5 dW dt times H plus dH dt times 5W. So that's how you would do it. And that's more of an example than an always true statement. All right, so typically one of the sides is going to be constant. Sometimes they'll have two sides as constant. For example, the length and the width are both constant. This is a problem that will show up in Monday's lesson. Both length and width are constant. If you think about like a well that is like a rectangular well, so when you fill up the water and it's always a rectangle, a shape time in terms of the top coming up, so it's a rectangular prism, but it can't go any wider and it can't go any in the left and to the right and up and down, so the length and widths are constant in that area, and the only thing that's changing is the water level's height. And so the water itself forms a rectangular prism, but L and W both being constant. That's typically what happens with the rectangular prism. I've really never seen the other one, but I'll do it anyways real quick here. So surface area would be 2LW, I'm 2LH plus 2 WH, and I'm not going to do it, but this would be just 3 product rules. Not gonna happen on AP exam unless 1 or 2 are constants. So I don't want to go too much into that one right there, but you have the formula. You can take the derivative. We've done a lot of practices. It'd just be a lot of, just like we did the one on the bottom left in red, you would just be doing that with the 2. So it'd be 2 dW dt times H plus dH dt times 2W. And in the end, you're going to have like 6 terms and stuff like that. But like I said, that doesn't show up on the AP exam. Next one. What was the next shape?
A cone?
Cone. Is that the last one?
Yeah.
Yeah. So that's the cone. This one has there's more extensions to cones, and this will be our last topic: problems and lessons on related rates. So this is more, in other words, in the few, and I'm going to come back to cones. So there's more expansions. We're going to come back to those cones problems where it's not necessarily constants. There's another special type of problem on there. I'm not going to cover it yet. We're going to talk about in regards to number one, volume equals 1/3 pi r squared times h, and these are problems. You might get a problem that's very nice. One of these, like height is constant or radius is constant. All right, so they might say that the radius is constant at 5. So you just plug in the 5 and it makes the problem very easy. The derivative is no product rule needed if you have one of the sides being constant, either the radius or the height. But if that's not the case, and sometimes it doesn't, sometimes there's multiple choice questions, and I think on your homework tonight it happens, dv dt requires what?
Product rule?
Correct. So if one of these is constant, it's nice because we don't need to use the product one. You can do that on your own. And then the last type of problem, which is a little bit trickier, we're going to devote an entire day just to be doing that special type of problem. So dv dt equals,
Oh, 2/3 pi r times drdt times h plus dhgt times 1/3 pi r squared.
perfect. Now, technically what some people do, I want to note that some people will do 1/3 pi, and then they'll do the r squared times h. So some, and I'm not going to write it because I think we feel more confident doing it this way. But if you did that, then dv dt would equal 1/3 pi, and then you would get 2r dr dt times h plus dh dt times r squared. These two things are equivalent. So this is just another way some people, so I don't know if you have somebody who helps you, be it a tutor, be it a a family member who's taking calculus or whatever it is, they might do the derivative this way and treat the 1/3 pi and just pull it out. But in the end, you get the same thing. All right. I just always have to choose. I found it's always best just to choose one method and one attacking style to the problems for the majority of us to have a better method of solving it. And so there are other ways to take the derivative, and some would say, well, this one's a little bit easier. To them, it might be. To you, I feel the way we just did it is the way that you're going to want to do it. So I just want to put that in there. I know, I know there's, you've got like, that's not how we did it. That's wrong. Or why didn't Mr. G show us that way? It's purposeful because once you get into here, you just plug in all your information. All right. Now, those are pretty much all the formulas we have. In your homework will be basically requires 1, identify the formula. 2, find the rate of change formula. And then 3, plug in and solve for rate in question. You don't have enough time to really solve a whole nother problem because most of it will just be writing down the problem. But I feel most of it is just going to be the same. For example, if it was this problem right here when we're talking about a cone, I would tell you, like, I would say something like, oh, R is 5 inches, H is 6 inches, dr/dt is 2 inches per second, and dh/dt is -4 inches per second. Find dv/dt. And so all you end up having to do is you just plug in each of these numbers and then you have your answer. Or I could give you dv/dt. Okay, so I could give you dv/dt, r, dr/dt, h, dh, and I might ask you, what's dh/dt? So you just plug everything in and then solve it as a basic math problem. I think the hardest part of doing this is finding those rate of change formulas. So you could kind of, get away with doing the problems by not doing and just copying down the rate of change problems from the notes. But I would say try to practice them on your own so that you get better at taking the derivatives. The other thing about the homework that can be a little bit confusing, the homework problem typically has a STEM question. So like question 1 has like parts A and B. The information in the STEM of the question will say things like the radius or the height is 5 and the length is 6. And then it says question A, the radius is increasing by and the length is increasing, or the height is increasing. It'll tell you the rate of changes for A. And then in problem B, they'll tell you new rates. What that means is that you're still using the same lengths from the stem of the question. So you got to go back to the top of it, and that's what the rate, or that's what the length is, and that's what the height is. So they're given to you up there. And then each problem has its own separate rates for you to get a little bit of practice with. I deleted quite a bit of problems, to let you know that. And I tried to make it so that you have usually just one problem. So if it's a circle problem, one of the questions is mostly probably just the area, and the other one is on circumference. And then if it's a cone, maybe it's 2 problems on the cones because it's good to have some extra practice. But the only thing that changes, and from part A to part B, is typically the rates will change. The rates will change, and maybe the variable formula that you're using will change. In other words, one of them will be area, the other one will be perimeter, or so forth. And that's what I have for you. So hopefully that helps. Hopefully you feel comfortable enough to move forward. Get that homework done. I'll see you on Monday.